Okay, so we are going to start Unit 5 today. We've been talking about exponents in all of Unit 4 and how to solve the equations and simplify them. And just like we did with linear, once we learn how to solve and um, solve for x and simplify the equations, we learn how to graph them. And that's exactly what we're going to do with exponentials. So this is called exponential functions. We are going to learn how to graph an exponential function or an exponential equation, however you want to say it, and identify key features of the graph. So kind of like when we talk about a linear equation and we have slope and y-intercept, this is going to be the different parts of an exponential equation. We're going to use function notation, which is what you see here as you look. This guy right here with this f of x, this is the same thing as when we write y equals, okay? But it's called function notation, and it's something you're going to see a lot of as we move forward and as you get up in your math career with Algebra 2 and so forth, okay? So this is the most basic exponential equation or function. And so just like we have with our linear and we've got y equals mx plus b, this is the same thing only with exponentials. So this is called f of x equals a times b to the x. Now, again, it has an exponent in it because we were talking about exponential functions, okay? A is going to be your initial amount. And when we talk about initial amount, this is always what we usually have is our y-intercept, but it's where we starting our amount, how much you have in the beginning. So it can be your y-intercept as long as you're not adding or anything, subtracting anything to the end. Can be the y-intercept. It's what we begin at every time, just like we do when we are graphing our slope. And this number cannot be 0. Okay? It can be 1, but it cannot be 0. B is the constant ratio. So just like in a linear, with our slope that happens over and over and over again, because it's constantly going rise over run, B is the constant ratio here. So it's what you're multiplying by every time. Okay, so I'm just going to put here what you multiply by each time. So if you're increasing by 3 times that amount every time, it's a ratio of 3. If you're decreasing and it's decreasing by a third the amount each time, your ratio would be 1/3. Okay, so B has to either be less than 1 or B can be greater than 1, but it cannot be 0. Okay, so less than 1 means that it's a decimal or a fraction, right? And greater than 1 means it'd be something over 1, but no negative amounts, okay? So exponential function is the product of an initial amount, so there's your a value, and a constant ratio raised to a power, okay? Exponential functions are modeled by this, f of x equals a times b to the x, okay? If b is greater than 1, then the exponential growth is increasing. If b is less than 1, then that means that it's an exponential decay, which means it's decreasing. Okay, and the final thing we talk about with with the exponential functions is an asymptote. Okay, the asymptote is this thing we add on at the very end. It's called c in this equation. It can be a positive or a negative. And we kind of see it here as we were looking at this definition over on this side. A function gets closer and closer to the line y equals c, but never quite reaches it. When a function approaches a line in this manner, that line is called an asymptote. So it's going to get really, really close to it, but it's never actually going to touch it. And that's the line that's called the asymptote, okay? So depending on whether this is a positive or negative, the line will move up and down based on that C value. So we're just going to put it here. The C value, or the asymptote, will move the line up or down, depending on positive or negative. So obviously up would be a positive and down would be a negative, okay? All right, so we're going to practice doing this a couple different ways. The first way is just by hand, and then I'm going to have you check it with a graphing calculator on a website, and then you guys can actually use the website after that from there, okay? So this first part, we're going to have y equals 2 to the x, and we're literally going to fill in our values that we've used way back when we were doing linear stuff. So the 5 values I want you to focus on are -2, -1, 0, 1, and 2. Okay, so we're going to plug these in for x, and then we're going to do the calculation and get what we have for y. Okay, so if I have 2 to the -2, we know that just from last week that equals 1/4. 2 to the -1 would be 1/2. 2 to the 0, well, anything to the 0 power is 1. 2 to the first equals 2, and 2 squared equals 4. Okay, so if we graph these over here on our coordinate plane, we're going to have -2, so left 2, up 1/4. I'm just put my line really close. -1, 1/2. 0, 1, 1, 2, and 2, 4. Okay, so as you can see, this one down here gets really, really close, but it never actually touches the line. And obviously, my drawing's going to be a little bit off with that. Okay, so growth or decay means we're looking for this B value. Remember, this is our B value. So we want to take a look at that for just a second. Our equation is y equals, or f of x equals a times b to the x. Well, notice there isn't an a, so that means that this would be a 1, because 1 times anything over here is going to give us the same thing. So 1 times 2 to the x. 2 would be our number that tells us that's our b. Is it increasing because it's bigger than 1, or is it decreasing because it's smaller than 1? And obviously 2 is bigger than 1, so this would be a growth. Okay, my y-intercept can be seen 2 different places. Here it shows you that it's 0, 1, and then it obviously crosses the graph on our y-axis at 1 here. So our y-intercept is 0, 1. Our asymptote is that line that it gets really, really close to, or the C value, right? So there's nothing out here, which would mean that it's like plus 0, and it gets really, really close to this 0 line, but it's never actually going to touch. So this would be y equals 0. Domain is always the x values in the function, and range is always the y values in the function. Now, our x values, if you notice, this arrow here means they're going to keep going this way forever and ever. And as this guy increases up this way, it's going to keep going out here just a little bit, which means it can go this way forever and ever. So that means our x values are going to be all real numbers. Anything works, okay? For our y values, however, this guy is going to keep continuing to go up, 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 like we talked about. So the y values are going to increase. But our y values down here, this guy's curving and is going to come really close to this value, but it's never going to actually cross it. So our range means it has to be greater than 0, because our boundary line, or our asymptote, is 0. So your range always has to be greater than what your asymptote is. Okay, it's got to be above that line. Okay, oh, sorry, I was going to check this. So now I want to take you to the graphing calculator. So if you'll type in your calculator or your computer right now, desmos.com, desmos.com, it will take you to a screen that looks just like this, okay? You don't have to log in or create a login. You're going to go straight to this graphing calculator right in the middle, okay? And it's going to pull up this really cool graph, and then over here on the right is your cursor where it's showing you to actually type stuff in. So our equation that we just did was y equals 2 to the x, okay? So the y equals part is already in the function of your calculator, so you don't have to put that in. So you just have to put in whatever comes after the equal sign. For us, that's 2 to the, and so if you look above the 6 on your keyboard, there's a little caret key like we have on our calculators. I'm going to push Shift and 6, and the cursor is going to raise up. You see it there? And I'm going to hit X. And automatically, it graphs us a line. Okay? Now, the cool thing about this is you can see that it gets really, really close. I can kind of put my pencil, my stylus on this line, and you can see that as I stop right here, that negative is the x, and the y value is getting super close to 0, but it never actually hits 0. And that's just showing you that that's the boundary line. That's where it's going to stay, okay? Has to stay above 0. All right? So the neat thing is, too, as you do these, you can kind of check your work because you can click on the settings, and a little table box comes up. You're going to click this guy right here, and the table of values actually comes up and shows you. So we had 1/4, then we had 1/2, then we had 1, then we had 2, then we had 4. So those are all actually on our graph right here, and then they're all actually on our table that we have over there. Okay, so this is a way that you can do this very quickly without having to plug all this in your calculator every time. That this site actually does it for you. Okay, so when I hit X, it just clears it off the screen, and I can go to the next one. So if you look back at our notes, our next one is y equals 1/2 to the x plus 2. So I'm going to go back to my calculator, and I'm going to type that in. 1, and just use your forward slash, and it'll create a fraction bar for you. Then arrow over so it's off of that fraction. So 1/2. Oh, I'm sorry, I forgot to put the parentheses in too. So I'm going to put parentheses over here, parentheses on this side, and then to the would be our little caret key with the 6, x. I'm going to arrow again so it drops off of that, and then plus 2. And you can see, again, it went ahead and did the line for you. And I can put points on here, and I can trace it, okay? And you can see what happens is that C value that we were talking about over here actually is what happens with the line. Like, here's our asymptote. It gets really, really close to 2, but it never actually touches it. There's 2.0000001. It goes all the way down to there, okay? But that's your asymptote. That's C value out here. And now I'm going to click on the settings and the table, and it's going to pull up a table for me. So we've got 6, 4, 3, 2.5, and 2.25. So I'm going to go back over here. Now I'm going to do 6, 4, 3, 2.5, and then 2.25. Okay, and this is, remember, our -2, -1, 0, 1, and 2. Flip back over and you can kind of see again. Okay, so I'm just copying the chart over. Now, we're going to graph them, and hopefully our graph will look just like this guy as we put them in there. Okay, so I'm going to have -2, 6, which would be right here, -1, 4, 0, 3, 1, 2.5, and then 2, 2.25. So again, it's going to come down here. And it's going to get super close to that 2, but it's never actually going to cross it. Okay, so my my b value, sorry, is a fraction. So this is a decay because it's going down. You can see that by the shape of the line as well. My y-intercept, well, it crosses at 3, so 0, 3. My asymptote is the c value out here, which is 2, so y equals 2. My domain is all of my x values from left to right, and you can see they go this way, and then the top one's going to keep going, so all real numbers. Okay, and then my range is my y, so it can go as far up as it wants to go, but it stops right here at 2. So my range is y is greater than 2. Okay. All right, hopefully that feels a little bit better. You can practice those as much as you want on Desmos and use it for your homework as well. Okay, let's keep going. So let's look at just this one. What are the characteristics of f of x equals 2 times 1.8 to the x minus 1? Okay, well, growth or decay, remember, is looking at that b value. Okay, so we're going to say, what's the b value for this one? Well, our b value is right here. 1.8 is bigger than 1, so it's a growth. Okay. My y-intercept is something I'm going to have to look at on the actual calculator. So I'm going to go to here. I'm going to close this one out. I'm going to type it in here. So I've got 2 times 1.8 to the x, and then minus 1. And there it graphs it. My y-intercept would be right here. So if you just touch that dot, it gives you exactly what the location is, which is 0, 1. You can also pull up your table and it'll give it to you there. Okay, so 0, 1 would be my intercept. My asymptote is whatever line is out here for the c, right? So negative 1. So y equals negative 1. The domain would be all of my x values. So if you look back at your thing, it's going to keep going this way forever. Whoops. Going to keep going to the left forever. And then it will go to the right at the top. So this is going to be all real numbers again. And then my range is my y values, and it can't go past this bottom line down here, which would be negative 1. That's your asymptote. So my y range is y is greater than negative 1. Okay? All right. So that's looking at the characteristics of an actual exponential function. Okay? Now we're going to flip it over and actually write exponential functions from the information that they've given us. Okay? So keep in mind, again, that your exponential function is y equals, or f of x equals, a times b to the x. A is my intercept, and b is what I'm multiplying by every time, okay? The ratio. So this first one, if you look here, 0, 4, okay, well 0, 4 would be my a value. A equals 4. That's your intercept. And then what are we doing every time on my y side? What's happening? So 4 times 3 would be 12. 12 times 3 is 36. 36 times 3 times 3. So my b value is what I'm multiplying by, which is 3. Okay, so then put those two together, and we've got f of x equals 4 times 3 to the x power. It's always got to have that exponent in there. Okay, let's go to this next one. So again, we're looking for our two things. The first one would be our y-intercept, which is right here. And if you look, this would be 1.2, which means this would be 1.4 on the line. So halfway in between there, I'm going to say that would be 1.5 as your b value, okay? Or your a value, I'm very sorry, your a value. Now, we got to get a couple points to be able to see what we're multiplying by. So this guy would be 0, 1.5. right? And then we can put another point right here at 1, right? So at 1, we would be at 0.6. And then here, a little bit more there. These two then, to get from here to here, we're actually multiplying again, but it's actually getting smaller, right? So 1.5 to 0.6. Now, this is a multiplication problem, so we can't put that we're dividing by a number, but you never know when you remember when we talk about if we're dividing by a number, we're actually multiplying by that fraction. Okay, so if you take 1.5 divided by 0.6, you should get 3/5. Okay, when you turn it into a decimal. So you're actually, for your b value, you're multiplying by 3/5. Okay, multiplying by 3/5. So our function is f of x equals 1.5 times 3/5 to the x. It's a decay, so it's smaller than 1. All right, last one over here. We're getting there. This says, here's my y-intercept right here. This is my a value. Okay, and then if you look again, we're going from 3 to 12, from 12 to 48, from 48 to 192. So we're multiplying by 4 each time. So that would be my b value. B equals 4. So I've got f of x equals 3 times 4 to the x. A is your intercept. B is what you're multiplying by. Okay, so now that we know a little bit about that, the last part is for you to actually distinguish whether or not it is a linear function or an exponential function. So linear, remember, is either adding or subtracting each time by the same amount. So add or subtract. And exponential would be that we are multiplying by the same thing every time. Now, whether that's a whole number or a fraction, either way, okay? But that would be an example. We're multiplying every time by the same amount, okay? So we're looking at the y values. So a little note to yourself to compare the y values, okay? So from here to here, here to here, here to here, here to here, right? Well, 7 to 4 is subtracting 3, 4 to 1 is subtracting 3, subtracting 3, subtracting 3. So if we're subtracting, that is linear. And explaining is just that it's decreasing by subtraction. Okay, if it were decreasing by a fraction, then that would be okay. All right, last one. This one would be here to here, here to here, here to here, here to here. So if you look, I could add here to get to this, but if I'm not adding the exact same thing again here, then that won't work. So for instance, like 3.5 to 7 would be adding 3.5, right? But then 7 to 14 would be adding 7. So we know we're not adding the same amount every time. And the only other way to increase it would be to multiply. And you should be able to tell that this makes sense to be times 2, times 2, times 2, times 2. So this would be an example of exponential because it has a multiplying every time. Okay, you're multiplying to increase. All right, so I want you to scroll down here on your own paper, and do these for your homework. There's a few more than normal, but it's a little bit of each kind so that you can kind of practice with the Desmos calculator on this one. And then down here, you're going to actually write your functions. So f of x equals a times b to the x for each one of these. And then this last part down here will be you actually telling whether it's linear or exponential like we just did. So use your notes, follow along, and let's see what we can do.